Hello everyone, so in this video we are going to discuss one problem involving the invariance principle. So we will discuss the invariance principle, we will solve this problem through invariance principle, and then also we will solve this problem through number theory as well. Okay, so solution through number theory is very easy, it won't take much time, but let's discuss the invariance principle way. Okay, so invariance principle is nothing but the principle is saying that you have to solve problems such that you have to figure out what is invariant in the problem, what is not changing, okay, so that it can help you to prove what you want. Okay, so there is nothing apart from that in the theory or whatever you say. So it's very pretty simple, but the main the question is like what is invariant, so that we have to figure out. So that's the hard part. So let's come to the problem. The problem is saying that you have each term either plus 1 or minus 1, okay, and there are n terms, and then this sum which is a1, a2, a3, a4, then a2, a3, a4, a5. As you can see, the sum is cyclically going and having 4 terms. Okay, so as you can see there are n terms, okay, because you see first term starting with a1, second term starting with a2, and so the last term starting with an. So there are n terms, and the other thing to note that each term is there in 4 terms, okay, because if you just look at a1, so a1 is there in the first one, it's there in the last one, it would be there in the second last one and the third last one. Okay, so each term is there in 4 of these terms, okay, 4 of these products. So now what we have to prove is that 4 divides n. So now you see that, like, if I just simply ask you what is not changing in this problem, so what property remains the same, what property remains invariant. So looking at the problem, it would be very hard to guess it, but now since we have to show that something with 4, so like we have n terms, okay, so let's think about in terms of modulo 4. Okay, so we have a sum, we have to show that 4 divides n. So an idea comes from there that we can work with modulo 4. So first of all, try to understand that like this sum is 0. Okay, so what we know is that like each of these products, okay, since each of these terms elements are plus or minus 1, each of these terms which are products, so they are also either plus 1 or minus 1. Okay, so you have like equal number of plus ones and equal number of minus ones, so that the sum is finally becoming 0, right? So now let's further think that like, okay, whatever be the combination of these AIs, whatever be the product, so I am given with a sum like S which is equal to 0. Now try to think that if I change one of these, like one of these terms, whatever if it is plus 1, if I change it to minus 1, and if it is minus 1, if I change it to plus 1, what's going to happen? So now try to think that, like, let's simply take this term, the first term. Okay, now let's simply think that if I change a1, so if a1 is plus 1, I change it to minus 1, and if it is minus 1, I change it to plus 1. So let's come to the first case, like a1 is plus 1. Okay, so if I change it to minus 1, so what happens is that this a1, a2, a3, a4, if that product is plus 1, then it changes to minus 1, and that product, if it was minus 1, changes to plus 1. Because of the sign change of one term, the product will change. Okay, so the sign of the product will also change. So because if that minus sign I'm removing and putting a plus 1, so that minus sign whatever, like if it was if the whole product was minus 1, so then the new product will be plus 1. Try to think it's very easy to see. Okay, because like I'm changing one minus sign to a plus 1, so the whole product sign will change. And again same, like if I change if there is a plus 1, I change it to minus 1, again that 4 terms product will change its sign. So for example, if I change a1 its sign, then 4 terms will change their sign, the first term, the last term, the second last term, and the third last term. So now let's see under modulo 4 how does this sum change. So what are the possible scenarios? Try to think. That is, I'm talking about these product terms, okay? So each of these 4 product terms, okay? So I have like 4 terms. I'm changing one of the AIs, okay? And it's involved in 4 terms, correct? So I'm talking about those 4 terms. They are changing their sign, so I'm talking about those 4 terms. So let's say that we are changing one of the AIs. I'm changing it to either, if it is +1, then I'm changing it to -1. If it is -1, then I'm changing it to +1. I'm changing the sign of one of these AIs. So it's involved in 4 terms. Now let those 4 terms be let's say that I'll talk about all the cases. Let's say that they are all +1. So these are not the terms I'm talking about. Again, AI is involved in those 4 terms, 4 products. Okay, so those initially, before changing the sign of those 4 terms, it can be all of them are +1. Okay, now I change the sign of AI. Okay, whatever AI is, I change it. If it's +1, I -1, -1, +1. So then these 4 terms will change their sign. -1, -1, -1, -1. Okay, so under modulo 4, this sum, okay, whatever like is the sum. So how does it change? So it was like +4 to it changes to -4. So the difference is, you can see it's like -8. So this can happen, or it can happen that all were -1, and then since one of these terms AI changes sign, all gets to +1. So then the sum changes from -4 to +4. So the sum basically changes from +8. So either the sum changes by a factor of +8 or -8. In this case 1, where all the terms, all those products, 4 products where AI was involved, either they were all +1 or either they were all -1. Case 2, 2 are same, 2 are different. Okay, so let's say any 2 are +1. I'm not saying the first 2 or the last 2, whatever. Any 2 are +1 and any 2 are -1. Okay, out of those 4 products where AI is involved. So they also change their sign. And so what happens? Nothing changes under modulo 4. Okay, so the first case you understand, like if the sum S changes by +8 or -8 under modulo 4, it still remains the same. Again, here also you see that it's 0. Initially here under modulo 4, this sum is basically like 0. Okay, and here also the sum is 0 modulo 4 again. So nothing changes. So now what are the other cases? The other case can be one of them is like +1 and the rest -1, or -1 and the rest +1. So -1 and the rest +1. Okay, so now -1 +1 +1, as I change the sign of AI, they change to this, and here also +1 -1 -1 -1. So now you see that initially the sum is like -2 modulo 4. Okay, so -2 modulo 4 is 2 modulo 4, and this is like it changing to 2 modulo 4. Okay, so basically the sum changes by a factor of 4. So here the sum is changing by +4. Okay, so from -2 it's going to +2, and then again here you see that the sum is 2, and here the sum becomes -2. So that means what? The S sum would then change by a factor of 4, plus or -4. Okay, if this is the case, then it changes by +4, and if this is the case, the sum changes by -4. So under modulo 4, the sum still remains the same. It's invariant. So this is the invariant thing. That is, this sum S does not, if you change one of the AI to from +1 to -1, or if it is -1 to +1, so S under modulo 4 remains the same. So that's the invariant thing. Okay, And so we have proved all these cases we have proved. Okay, so there are no more cases involving AIs and those 4 products. So now try to think. That is, here we have like this sum initially is 0, right? So now what I do is basically I go to those terms which are -1. So those who are +1 just remain there, and those which are -1 I change their sign. One by one I change their sign to -1 to +1. So what happens is I finally like take all the terms to +1. So, but I know that changing sign doesn't change the sum under modulo 4, right? So that S basically suppose changes to S dash, okay, where all the terms are +1. So all those 4 products, the first 4 products will be +1 because I've changed all the minus terms to +1. So finally I will be having n such ones because there are n terms there. So n ones because all the AIs are now 1. And now I also know that like S and S dash would be congruent to same under modulo 4. Okay, because the sum remains invariant under modulo 4 if I change the sign of the AIs. So then S was initially 0, so S dash will also be 0 modulo 4. And now you see that S dash is nothing but n ones are getting added up. So n is congruent to 0 modulo 4. And so 4 divides n. Okay, we are done. Now this was the invariance principle solution. Now what about the number theoretic solution? The number theoretic solution is very simple, as we discussed initially. That is, there will be half of them will be -1 and half of them will be +1, right? Half of them -1, half of them +1, correct? Because the sum in S, the sum has to be 0, okay? And each of these products are either +1 or -1. So finally, to become 0, we need half of them to be +1 and half of them to be -1, so that they will get cancelled out, okay? And so if half of them, which is suppose k are -1 and k are +1, so the total number of terms is n. So we get 2k is equals to n. Okay, and so k is the number of terms, those 4 products, such that they are +1, and similarly equal number of -1s are also there. So then we get that 2 divides n. Okay, so now next what we have to prove, 4 divides n. So further what we have to prove is that to prove 2 divides n by 2, because 2 divides n, I know that n by 2 is an integer, and so I have to prove that 2 divides n by 2. So now what I'll do is, again I know that half of them, like what I'll do is I'll take the product of all these 4 terms. Okay, so all these 4 terms I'm taking the product now. So S is the sum of all those 4 terms. Now I'm taking the product of all those 4 terms. So each term I know is involved 4 times. So a1 to the power 4, a2 to the power 4, so on till an to the power 4. So this is what's going to come. And now try to think, this is what? a1, a2, till an whole to the power 4. Okay, now this is what? Basically this is like either the product inside it is either +1 or -1. We don't know. But whole to the power 4 we know it's always going to be +1. But looking at the other side of the product, what we know is like these products, I know that half of them are +1 and half of those 4 products are +1. So -1 whole to the power n by 2 and +1 whole to the power n by 2, because I know that half of those 4 products are +1 and half of those 4 products are n by 2 terms are +1, n by 2 terms are -1. So the product is -1 whole to the power n by 2 +1 whole to the power n by 2, and which is basically -1 whole to the power n by 2, and that is basically equal to 1. So finally we get -1 whole to the power n by 2 is 1. So which implies that n by 2 is even, which is of the form suppose 2m, and thus we see that like n is equals to 4m. Okay, and thus 4 divides n. So this was the number theory solution. So I hope you like the solution. So if so, please don't forget to put a like, and also please do share it among your friends who need such guidance. And yeah, thanks for watching, and see you in the next one.